All right, new day, new laptop to repair. This time we have a Dell XPS 15. This is the 9500 edition, so this would be like a 2020 model. The customer sent this in because they changed out the palmrest touchpad assembly with the keyboard, and when they put it back together, the laptop would no longer turn on. So I haven't looked at this yet. Let's see if we can figure out what happened to this machine and see if we can get this saved. All right, so the first thing we're gonna try, let's see if it turns on. I'm not seeing any lights or anything. Let's plug in the power. All right, so it is negotiating the 20 volts. The way USB-C works is it starts out at 5 volts, talks to the laptop, and then goes up to the 20 volts. Now we're looking to see if it's pulling any amps, and it's pulling 0.01, 0.02. That's generally good. That means that the EC chip is coming on, which is the kind of acts as a startup chip. And it is a microcontroller that's listening for different key presses, like especially like the power button. So I'm pressing the power button, nothing's happening, but it's talking directly to that EC chip. And so what is supposed to happen when we plug it in is you'll have it go up to 0.01, 0.02, and then go back down to 0 on this machine, and then it will listen. But it's not doing that, and so let me plug it. Let's try a different port. Still the same thing, 0.01, 0.02, which again, it's not bad. It's almost like the power button's not plugged in. That'd be interesting if he just didn't even plug in the power button when he put it back together. It could be something simple like that. But we should see battery charge current, and I'm not seeing any of that either. So, all right, let's open up the bottom. We'll have to take a look inside. Okay, one thing I noticed is it's missing the little acrylic plastic light cover here. That's just missing. It's not a big deal. It's just cosmetic, really. But all right, and the bottom is off. Okay. So we have, here's the main battery. It plugs in right here on the board. And let's see if this battery has any voltage in it. We're gonna put this in voltage mode, and then I'm just gonna measure here on the contacts. I just wanna see how many volts we have on the battery. All right, so the battery's at 0 volts. So whenever you have a battery that's plugged into a machine that's at 0 volts, most of the time it's not the battery at 0 volts. It's usually the battery's shut off because the computer has a short on it somewhere, and it's saying, hey, don't supply power. So it tells the battery to shut off. So whenever I see that, I don't think the battery's completely dead. I usually think it's shut off. Let's plug in the charger, and let's see if we can measure and see how far the voltage goes before it stops. So I'm gonna plug it in here. Actually, let's get under the microscope. Okay, and you see someone's been in here, right? Look at those screws. Okay, so here are the USB-C ports. Let's plug in the power into the USB-C. Okay, we got it up to our 20 volts. And the way that works is the voltage will come through here, and it will talk to this chip. This is the PD controller chip. That's going to talk to the charger, and then it's negotiate the 20 volts. We know that's working because it's up to 20 volts. And then it's going to send the voltage over to one of these two chips. Each one of these chips handle each one of these. So let's measure the first one. And I got nothing there. Let's check on these inductors. We got nothing there. So let me check this other one. Okay, so this is the one it's getting sent to. So it's getting sent into this chip. And then this will, whenever it's turned on, it will let the voltage come out the back of it. And it's on. So it's allowing the voltage to come through. So we have our 20 volts here. And then that's going to come over here. And so this is going to be where our main power rail is generated. It comes over here. See, here's our battery connector right here. And then this coil right here should be our main power rail. And so what we do is we have the voltage come through here. It comes to this MOSFET. And on this side, we should have 20. And on the other side, we should have not 0. We should have 13, I think, 13.6, 12.6, something like that. I can't remember. It's going to be battery voltage. I think on this machine, it's 12.6. And we have 0. So that means that we're not getting voltage to the other side of this. It means that there's a power management controller chip that actually controls this MOSFET. And the way a MOSFET works is it's an on-off switch, more or less. And there's we have 4 pins going in, 3 pins going out, and then we have a gate pin which toggles it on and off. And let's measure what voltage we have there on this gate pin. We got nothing on that. So, but what it does is it pulses that pin with a PWM signal, and then that's going to reduce the 20 volts down to the 12.6 that it needs, and then that's going to go through this coil, which is going to clean out the spikes, and then we'll go through a big capacitor, and then that will smooth it out and make that 12.6 that the motherboard can use. So we know that the voltage is stopping here, and it's not getting past there. So why is it not getting past here? We don't know. When we have this type of issue, it could be the actual MOSFET itself is bad, but I don't think that's the case. Because we're not getting any voltage here on this pin. And if we are not getting voltage here, then that means that the power management chip is not telling it to turn on. So if it's telling it not to turn on, it could be because the power management chip is detecting a short on the board somewhere, or some sort of issues like that. Or the power management chip is just bad. Or the power management chip is not powered on, or there's quite a few other things. But so now we can know we don't even need to check past this because it doesn't have, there's no voltage there anyway. One thing I want to check though, since we have 0 volts here and we know that the charging circuitry is not working, let's see if the laptop is actually working on battery. And so the way I like to do that is this battery is dead or it's off, right? Let's plug another battery into it and that's charged up and see if the laptop will turn on. So let me try that. So I'm going to unplug this. All right, so I have a test battery. I keep a battery for every machine. My company specializes in Dell and Alienware, so we stock pretty much every single part for every model, and they're all going to be genuine Dell OEM parts. And so what we also have is a test machine for every single model of Dell. I must have, I don't know, 120 models in my test area back there. So every part that comes in, we test it on there. But so here's a test battery I have. This one's already charged up. We'll be able to just plug it in and see if this laptop turns on. It's funny because some people will think like, oh, because it's not, you plug in the USB-C ports, we know the whole motherboard's bad, and it's, it could not be something catastrophic like you're thinking. It could just be that the charge circuit's not working. So I'll plug in our battery. I'm going to measure at the ports, the battery port here, and we got 10 volts. That's pretty low. Oh, I sparked it. Watch out, don't touch ground. Okay, we got 11 volts. So I must have not had a good connection. Okay, so we have voltage on the battery. Let's see if this thing will turn on. You ready? And let's hit the power button. The fans are spinning up. What does that mean? What does that mean? Does that mean it's gonna work? Spun up for a second. Let's try it again. Oh, look at that. Our Dell screen came up. Got a backlight. Okay, so now that we see that it actually is turning on with the battery, then that rules out any shorts on the motherboard, doesn't it? That means that the power management chip is not preventing that chip from coming on because it detects a short somewhere. So that rules that out. But we don't know why it's not working still. But let me plug in the charger now. We have a good battery in here and see if it does anything different. Okay, charger's plugged in, still pulling 0 amps. So it means it's not even trying to charge. I'm going to try one of these ports on this side also, just to rule that out. And that was sitting at 0 volts also. All right, but we can confirm that the laptop is working fine. Let's see if we can go into the BIOS. Yep, so the laptop's working fine off battery. So that's not going to be, so the issue is going to be only in the charge circuit. Again, the only reason why this is not working is because the customer changed out the keyboard, palmrest, and touchpad. So I guess he changed out this whole top assembly here. And when he put it back together, it stopped working. Now, I don't know what he could have done to break this, but I can tell you what I've seen in the past is taking this bottom cover off is really hard. It like sticks. It's basically snapped on here, and you have to get a pry tool in here. And so what I've seen is people will pry at it trying to get it off. And so that may be the case where you actually pried and ripped some components on the edge. I think the next plan of action would be let's remove this motherboard, and then we'll do a physical inspection everywhere and see if we have any missing chips or any burnt chips or things like that. So let me get this board taken out. I was just unplugging these Wi-Fi antennas, and neither one of them were plugged in all the way. And they just installed the bracket on top just to hold it in place. But I mean, I don't blame them. These Wi-Fi antennas are very hard. They're very tiny, and they're very hard to get installed properly, and they can get mangled very easily. So let's see if they are actually damaged. A little bit bent up. Well, this one's pretty bad right here. So we'll see if we can get this installed properly. You know, this is soldered on the board, and it's just more of a pain to actually try to replace that. But just one more sign that you can tell somebody's been in here. Okay. Ooh, this connector didn't look like it was plugged in straight either. This is, I think it's the webcam connector. Let me see if that's damaged. Looks okay. Okay, well, let's get this board out and then we'll look around. All right, the motherboard is out. All right, so where I want to look first are going to be the edges of the board, because that's where the pry tools end up poking. So I'm going to check the edges of the board real quick. No issues there. Okay, let's check this side. All right, that looks okay. All right, I'm going to pull this back and we'll just look around, see if we can find any burnt components. I'll just take the whole cover off. So there's that power management chip we were talking about. So there's a possibility that this is bad. So I do have more of these. We can install that if we need to. We're going to check it in a second, but I just want to look around first. There's the BIOS chip. This is just sticky from the cover that was on there. All right, and here's the EC chip. This is something else that could be bad, even though it is turning on, but the EC is what actually talks to the power management chip to do charging, so we could have an issue in here. And here's the 3-volt and the 5-volt power rails controlled by this chip right here. And there's a possibility that when he changed something out, he could have sent something down the 3.3 power rail and damaged that EC chip. So that's something that we could change out if we need to. That all looks fine. And then this is the 3-volt, 5-volt power rail. That's the other side. That's the board. There's that Wi-Fi card that's all mangled. There's the power button with fingerprint reader. And then this is just a connection that goes to the SD card reader and audio. That's the webcam. That's the LCD screen. These are the inductors for probably the GPU. And then there's our RAM. All right, this is the main power rail area that we're talking about. Is that hot? Is that messed up here? So let's take a measurement over here. I just want to see what we're measuring on this coil. Now we shouldn't have any shorts because we talked about that already because the board's working, but we could still have a partial short in something. So in continuity mode, no voltage in the board. That's not an issue. And here's this current sense resistor, that's fine. That's fine. Here's our keyboard connector. So another thing to think about is because he was actually interacting with this keyboard connector, this also talks straight to the EC chip and talks to, well, I guess the EC chip only. So it talks directly to the EC chip, and he could have burned out the EC chip. That's why it's not turning on with the power button. So everything else looks physically fine. here's what I want to do. Since we have it out of the machine and now we don't have anything plugged into it, let's plug the power into it and see if it acts a little different. Now, because I don't have a battery plugged in, it's going to go through a CMOS reset, so it should power on immediately and start pulling amps. I don't even need to hit the power button on this one. So I'm going to press that, and it's still sitting at 0.01. So I want to figure out where that 0.01 is going. It's probably going to the EC chip, which we talked about is right here. But let's see if we have voltage over here. Is this getting warm? I can't tell. Let's measure the voltage right here. Uh, 0.3 volts. That's not right. We should have 3.3 around here. It should be on these capacitors. So is the LDO not coming on? That's interesting. The LDO is a linear voltage regulator that produces a 3.3 volt power that powers that EC chip. Because when the board's off, we're not running a bunch of the switching power supplies. So it's just using that linear one that only produces 150 milliamps, just enough to be able to run this microcontroller. But if I'm not getting voltage here, that means we're not even getting that. And so I think that's actually produced on the power management chip. So let's measure over here. We should have, on these two pins, we should have 20. Got 20 here, and then got 20 there. This next one I think is supposed to be 5 volts. 5 volts, so that's the enable for that. And then this one should be 3.7, is that right? I can't remember. And we're getting 0 there, whatever that is. And then these are supposed to be 3.3, and I'm not getting any voltage on there. Okay, so the measurements on here is a little bit strange. We've got 4.7 there, but nothing here. So this actually, to me, is looking like a bad power management chip. And I think that's actually the quickest and easiest thing to start with. So let's change this power management chip out. Like I said, I do have more of these. This is going to be the ISL, I think a 9538CH. Yep. It's an ISL 9538CH. So I have more of those. Let's get this removed and we'll put a new one on. Okay, this one we're using 450 heat at 60% air. This board's a little thicker, takes a little bit more time to heat up. So we're just gonna heat up the area. All right, and it should be hot enough. All right, and we got it off. And so while it's hot, I'm gonna go ahead and add some fresh solder to the pins. And I'm not going to worry about adding any in the middle because there's already enough there. I just like having fresh solder on these pins on the side. And so let's grab the new chip. (9538CH). These chips are kind of expensive. They're about $8. And I haven't been able to get them in the States. So I have to order them overseas, which adds more time. That's why I always stock them. All right, because we're working on a Dell, it tells you what pin 1 is. That's that mark right there. There's our mark right there. I want to prep this since it's new. I want to add some solder to these pins around here real quick. Let me do that. That way it sticks better and we don't have a shortage of solder. Not much, we're just putting just a dab on there. There we go. All right, let's get this installed quickly. Wait for the solder to melt and we'll set it on there. Perfect. And you see how it kind of seated itself? We're going to add some flux. There we go. Just like that, we have the new power management controller chip installed. And let's clean up the area and let's see if this board works. All right, now that we got it cleaned up, I'm interested to see if this will work. We don't even need to reinstall it to test it. All we're going to do is just plug it in. It should power right on. It's going to work. And it's doing exactly the same thing. So if it's not that, I'm thinking it's going to be the EC chip, especially since they were messing with the keyboard connector. And there's really no good way of testing to figure out if that's the issue. The way these EC chips work is they're programmed through the BIOS when it comes on. And we know the BIOS is working. And we know that it's not a programming issue on the EC chip. It does run off battery, which makes me kind of suspect that it's not the EC chip because the power button does work on that. I have to think about this. Let's see what the power management chip's producing now. Let's go ahead and measure the voltage around there. Because it might be one of these other pins. Okay, so we should have 20 here, right? 20 there. We have 5 here that turns it on. And then what was this one supposed to be? I don't remember. I feel like this is supposed to be 3.7 volts because I've worked on a lot of these. And that's nothing, and I feel like that's supposed to be something. So let me grab a donor board and we'll take a look at what those measurements are supposed to be. All right, I got a donor board here. Let's see what this one is saying. Right. Plug in the power. And it only says 0.15, so this one's not even powering on. And again, I have a lot of donor boards up there. They're broken for different reasons. But what I want to do is I want to figure out what voltage you're supposed to have here. 3.7. That's why I was right. So 5 volts here, 3.7. Why aren't we getting 3.7 on this line? What are we supposed to have on the back side of that? Nothing on the back side, but 3.7 on this side. What about this one? This one we're supposed to have 12.8 or 12.58 and a 17. Okay. All right, so I was right. We were supposed to get the 3.7 there. This is from me measuring it. I think I just scratched it. So I'm not sure why we're not getting that there. I'm not really sure where it's produced. But this may... let me plug in a battery and see if it shows up. We have our test battery here. Because if the EC chip's working with the battery plugged in and it charged, then maybe it's getting the voltage there that it needs. And maybe that's goes to the EC chip. I don't have schematics for these things, so it's kind of, you just kind of have to figure it out as you go. You got 0 volts there. $11.2, 11. .8. So we're still missing the voltage that we need right here, and I don't know what this 3.7 is. We can put the 3.7 on there and see if it actually turns the chip on. We can try that. It could be that the chip produces the 3.7, or it could be that the actual power management chip is what's producing that 3.7, or that the motherboard is producing the 3.7 and sending it there. So let's go ahead and inject 3.7 volts there. All right, so I'm going to inject 3.7 volts on that line, and I don't want to put too many amps through it, so I'm going to set this to like 150 milliamps. And so we're at there we go, we'll do 3.6. Okay, so when I apply it onto that line, what do we get? It jumped for a second. Let's see what the... Oh, okay, interesting. Let me switch this back to this view. So I'm gonna put that 3.7 on here, and I want you to look at the power being pulled off the USB-C. Jump to 1 amp for a second. Let's see if it comes back on. And the board's posting. The board's powering on. Okay. So what have we determined? We determined that that 3.7 is missing now, and that the chip's probably not producing it. So where does that go? I have no idea. So we're gonna have to try to figure out where that 3.7 is actually being produced, and it could be any of these little chips around here. And I will have to kind of figure this out. I wish I had a schematic for this. Actually, I wish I had a board view for this. That would be the main one. I probably have a schematic somewhere for this, but I tend not to use schematics just because I'd rather fix them without them, because I don't want to rely on them. But we need to figure out where that goes, and it's going to be very hard to know where that goes. But I'm assuming it has to be somewhere on the edge if he broke it off, or it's something burned that ties into that. All right, let me see if I can look this up on schematics, and we'll see what we can come up with. All right, I found a picture of the schematic of the power management chip here. So here's the power management chip. There's pin 1. And what we're looking for is, so here's the DC in. And I think this is the pin we're looking at, pin 19. That should have that 3.7. If we look here, there's a via, so we only have this capacitor on this line. That's all we see. And so the rest of this is somewhere else. And so I got to figure out where those are. But we can measure to pin 20. So if we see 20 comes over here and ties to ground, it's tying straight to ground on pin 20. But on here, they're showing that, oh, actually, this one goes somewhere. It doesn't even show. So we have to figure out where that is. That was my mistake. So this is 18 that does this, and that's creating that VDD. So 18 and 20 are tied together. That's why to find this issue or figure out where this goes, it'd be easier if we had a board view. I'm going to try to look around and see if I can find one, but we're going to have to just figure it out the hard way. So let's see. I'm in beep mode where the probes beep, and let's see if I can just hold my probe here and let's touch around and see if we can find another spot that it's interacting with. It's probably going to be on the other side of the board, unfortunately. But we're just going to touch around, see if something shows up. This is definitely tedious because there's no guarantee I'll be able to find it this way. There's so many chips on the board. All right, still can't find any board views, but here's what what I did is I have, this is the good board, or the test board that I have that we measured the 3.7 on that pin. And I'm trying to figure out where it goes through the board to the other side. And I just started measuring some components over here. And what I'm trying to find is that 3.7. So if I measure, because it kind of seems like the vias are coming through underneath this battery connector. So I measure right here, and I get 19 volts. If I measure right here, I got 3.7. This is 0, 3.7, 20 volts. 20 volts, and then this is 20 volts, 12.6. All right, so this must be the AC detect circuit right here. So we may have a bad, one of these might be bad, or a resistor may be bad on our board. So let's check that out. All right, so here are our chips. So we measured, on our test board, we measured that we had 12.6 here. We don't have that there. We measured 20 volts here. We have 20 volts here, and that comes to here. And then we have 20 volts on this side. We do. And then we also had 20 volts on this side. And we do. And then, so 20 volts on this side. What about on this side? 3.7 is what we're supposed to have on that side. And so this is 0 all the way across here. So I'm wondering how this is supposed to become 3.7. And I think based on the, well, I guess the schematic didn't show us what this is going to be, but wait, is it burnt? Oh, kind of looks burnt, doesn't it? Can you see that spot on top just a little bit? Right there, that little dot. We might have a bad resistor. Let's measure it. We're in ohms mode. It's kind of hard to measure resistors inline, but we're measuring something across there. But it's going to infinite resistance. It's going really high, like it's filling up capacitors. Let's measure our test board to see what measurement we're supposed to have there. Okay, here's our test board. So it's still filling up the capacitors too, just the same way. 160 ohms. This one's 100K. And going down a little bit. It's 140. I want to kind of remove one of these resistors to see if it's shorted across there, because I'm not shorted. I want to remove one of these resistors to see if it's open. I kind of see a little discoloration, a little dot there on top that makes it look like it's bad. So let's take this off and measure it and see if it's measuring open. So now we can take a true measurement of what that resistor is measuring. 440 kilo ohms. And this one was 100 kilo ohms. And so if it is a true voltage divider where this is ground and it's going to 20, that ratio would put, let's see, if we do the math. Yeah, so I did the quick math. So if we have, this is 100 kilo ohm, this is 440, that equals 540 kilo ohms. And then we're only going to be pulling off this 100 kilo ohm portion. So that if you do that as a multiple of the 20 volts, this is 18% of the 20 volts, comes out to 3.7 volts. So it probably means that this is the one that's not working. But let me plug the board in now that we have that one pulled off of there. And we'll measure over here again. I just want to see what we're getting. All right, we got our 20 there, and this was going to be the 3.7 if it went through that capacitor. All right, I mean, I keep saying capacitor, if it went through that resistor. Let's pull this one off and measure, because this isn't going to have anything on it. But that's interesting. It doesn't make sense, because if it does have 20 volts here, and this thing is measuring at 440, did it just not have a good connection? I'm going to stick it on here real quick. Let's see what it does. Let me solder this back on, and then we'll test again. All right, I have it soldered on there. We're going to plug it back in. Let's take our measurement again. Still don't have anything here. So that means it must not have a clear source to ground. So let's take this one off and measure. Unless this ground is not showing up right. This is definitely ground. Let me measure all the way to here. Let's see if we get 540. We only have 41 kilo ohms. Why do we only have 41 kilo ohms there? Here, I switched the probes around. I put the negative on ground here. So it might have been filling up capacitors, but there may be a shorted capacitor on here. That's measuring 94 or 100. And this one inline is only 140. 150, but it's still filling up. You can see it going up. That means it's a capacitor that's in line with it somewhere. So is it this capacitor that's bad? because that's the only capacitor that's in line with it, right? Let's check. This capacitor, let's see if this is measuring. So that one's measuring across that bottom resistor. I don't see why that voltage divider would not be working. So let's pull this resistor off, like I said, because we're gonna have to pull off everything in this line in order to fix this, because we don't know which one of these components are bad. So I'm gonna pull that resistor off too. Okay, we got it off of there. And let's measure it. 100. Okay, let's measure across here. 90. That's 90 mega ohms. Okay. So now what I want to check is I'm going to plug it back in. I'm going to see if this is getting pulled, if we're getting our higher voltage there. Because we should get something through that too, that resistor. I don't know why we're not getting voltage here. Because we have 20 volts on this side. All right, I'm just going to replace both of these, and we'll continue. All right. So I have a donor board. I'm going to grab both of those and get them replaced. All right, we got them both replaced. Now the question is, did that fix it? We don't really know. And what we're still kind of trying to figure out is, you know, I mean, this is on the edge of the board, so it could be that he poked it with a screwdriver or something like that. Burned out something, shorted something out, because the battery's connected. But we don't know what's going on, so let me plug in the power again. All right, power's plugged in. And we're not pulling any current, so we know that this can't be working. And so we're still getting 0 volts. We got 20 volts here, we're still getting 0 volts here. So we got to figure out why. I mean, this ground is good, right? That should be ground. I think we measured it as ground, right? Yeah, so if I measure from here to here, we got 20 volts. I measure from here to here, we got 20 volts. So this is grounded. So if I measure from here to here, I got nothing. So it's basically grounded. So this is shorted to ground. So that leads me to believe that this capacitor right here is bad. Let's take this capacitor off right here. It might be partially shorted or something. You know, it's funny because I said that I scratched it, but I wonder if that's a crack. That'd be interesting that that's a crack the whole time, and I was like, oh no, I just scratched it when I was measuring it. Okay, we got it off of there. I don't know. Well, here, yeah, so let's go ahead and put a new one on, a new capacitor on there, off the donor board. What's great about donor boards is you don't need to know the values of all these components. You can just grab them and transfer them over, because they're the same part number of board. Okay, there we go. We have that installed now. Let's cool it off a little bit. Okay, so let's plug it in and see if we're getting our 3.7 that we need for the AC detect. And we're still not getting it. So it was not that. I thought for sure it was that. We're running out of things to change out. So why are we not getting 3.7 here? So we know that this isn't shorted. Is there any other capacitors on that line? What else could prevent that from producing that 3.7 volts we need? Got 20 volts here. It's trying to go to ground. Here's ground. It's going through 2 resistors. A voltage dividers, you have two resistors in line and you tap off the center and then it will take the voltage off of the lower resistor. So we have a 440 up here, a 100 here, that equals 540. And then 20 volts is on top, ground's on the bottom. You tap off at that 100 and then that equals 3.7. Why are we not getting that? I know I need to clean up this solder joint a little bit. I can see some other junk in here. All right, so let's inject the 3.7 right here and see what happens. I'm not going to put power on the board yet. I just want to see if something gets hot or if it starts pulling some current. We still have our power supply set to 3.6 volts. We have it limited at 150 milliamps. And let's see if it pulls any current here. And it's not pulling any current. Okay. So now I'm going to plug in the charger and see if it boots up when we do it again. So charger's plugged in. I'm putting 3.7 on here. And it's starting up. There you go. We got the power light coming on the motherboard. And it's starting up. But one thing I did notice, did you see the, oh, yeah, interesting. So keep an eye here, look. Let me try it again. I'm gonna plug in the charger. It's coming on, and then this dropped down earlier to 1.2 volts. Why is it dropping down to 1.2 volts? Maybe whenever it's on, it's supposed to be low like that, and it switches something, diverts the power. Maybe because I don't have enough current on there, because I have it current limited. But point being, it's working whenever I inject the voltage there. So I have to figure out what is causing this. All right, let me think about this. I'm going to look around a little bit more, and I'll be right back. All right, we're back on our test board here. I'm just taking some measurements. So you can see that we have our 20 volts. Has this not been working the whole time? I'm sorry, guys. I just realized that my voltmeter has not been showing the entire time. Okay. So you missed a lot of measurements, but I can tell you here. So we're measuring 20 volts here. And then on this side, we're measuring 3.7. And then this is ground, so 3.7 here. So from here to here, we have 20 volts. And from here to here, we actually have 16.29 because it's a voltage divider where the 20 volts is going through all these. And then if you measure across that, we have our 3.7. If we measure across this, we have the remainder voltage. When we measure on our board, we're actually getting 20 volts right here, almost as if this is shorted across somehow. So if that's shorted across, though, oh, no, almost as if this is shorted across because we're measuring from here to here, it gets 20 volts, meaning 20 is here, and this would be ground. So from here to here, it doesn't measure anything different. So it's almost like across here is shorted. But I don't know of any other component that's across that. So we're still needed to figure out what component is in parallel with that. All right, I was looking at this picture again, and so here's the pin that's supposed to have the 3.7 on it, and I didn't notice that it actually ties to here. And so here's our 20 volts, and there's that 440 ohm resistor we were talking about, and then here's the 100. So here's our voltage divider, and then it taps off the center here and jumps over there and gives us our 3.7. So this is circuits right, and so this capacitor that's in parallel with this almost seems like it's shorted or there's something going on with this area, because when I measure here and here is basically ground, but I'm not. When I measure in resistance mode, I'm still getting the 100K, or it's this right here, this ISL 8873 chip that might be shorted. That might be what's going on, or it's pulling it low. but we still need to figure out where that stuff is. So anyway, I'm just going to keep looking around here. All right, so the next day I had to give up, and it was frustrating me that the voltage divider just didn't seem to be resolving the issue, and it didn't make sense to me. And so I wanted to take a day and kind of think about it. And let me reassemble this machine. I want to see if everything's still working off battery and if we can trigger it to run off the AC adapter. So let me quickly reassemble this. All right, we got the motherboard temporarily installed. Let's plug a battery in it that has a charge. All right, so this laptop should power on off the battery, because that's what we had seen in the past. And there we go, we have the Dell screen. I'm gonna let it go through this CMOS reset. We'll reboot a couple times and I'll be right back. All right, so there you go. So it did go ahead and successfully post. I'm going to turn it back off. We're going to boot into the diagnostics, so we have a view of the charging circuit. I'll hold down the FN key and turn it on, and that will boot straight into the Dell diagnostics. Okay, now that we made it to the Dell diagnostics, we can just cancel out of this. We're just going to try to, we want to see the view where it's viewing the battery and charge current and stuff like that. All right, so the battery's charged at 19%. It's pulling 2.8 amps out of the battery right now, so it's discharging. Let's plug in the charger. See what happens. Nothing happens. And then let's inject let's inject this 3.7 volts in there. So I'm just gonna put it in on that point, on that voltage divider. What I'm testing for is I'm trying to see if this actually does trigger it to start charging. Oh, look at that. It's detecting the AC adapter now. Switching to idle says charging. Okay, but this should be a positive amperage here, and we're still negative. Originally it was pulling 3 amps, and now it's pulling only 1 amp. So it's only putting 2 amps in there. Let's see what the power meter says. Power meter says it's taking 1 amp out of the charger. So it is detecting the AC adapter now whenever we actually inject that missing voltage. It's saying it's charging, but then it's not actually pulling enough current to charge. Interesting. Oh, look, and I just removed it, and it still says it's charging. Well, it still says, yeah, still says charging, still detects the AC adapter, but now the amperage has dropped back down to it not charging. Let me put it back on and see what it does. And it's not switching back now. Okay, so I'm starting to think there's some other issue that's not the voltage divider. You know, we're looking at this voltage divider because it makes perfect sense that it should be able to detect that the AC adapter is present or not. But even with us injecting that voltage there and telling that it's present, it's still not working all the way. Let's take another look around this board. Let's see if we can figure out if, I mean, there has to be some sort of physical damage on this board that this customer did. Other than that, I'm running out of options here. Let's look at what we've been working on. Here's the area where that voltage divider is, and you can see it's starting to get kind of worn out because I keep injecting that voltage right there, but I've replaced those resistors multiple times, and I verified that all that is working, but it's just not getting it through there, and to me it seems like there must be something pulling this part of the line low, and which could be a pull down resistor or something like that, or it could be a transistor that's being controlled by a microcontroller or another type of logic chip. And I don't know, because I can't find board view. I actually found more of the schematics, but the schematics they're not telling me where things are. They just tell me how things are wired, but it's not going to help me find the issue. So, and again, I still suspect that a chip got ripped off the board when they were taking this out, because that's what I've seen a lot. Whenever somebody takes something apart and it doesn't work anymore, there's the power management chip we replaced. So I'm always looking on the edge, because the edge is going to be where the tools are going to be hitting, you know. So, well, there's something. Well, that is something that could definitely cause some issue. That's a resistor, and this is a missing item, which is probably another resistor since we have a bunch here. And this is definitely in striking range of a tool. So we might have found the culprit, I hope so. The problem with that is, let's see, PD2200, PD2200, PD2200. Let's see if we can find what the PD2200 is. PD2200 is right here. And guess what? Look at that. AC detect, ACN right here. That's going to that line that we were talking about. So here's our power management chip. And this is that line that has the 3.7 on it. Here, that connects over here. And here's that voltage divider. We have 20 volts on the top, ground on the bottom, 100K, 442. Tap off the center, you should get 3.7 volts. And when we're measuring here, we're not getting that, but this goes and connects over to this area also. And so if we go back to where we were, so it connects right here. And that comes through, it looks like a transistor of some sort, or a MOSFET. PQ is usually a MOSFET, I think. And then there is this Zener diode. And that is what's marked on here as PD2200. Now, I don't know which component that is, but we have a bunch of resistors here. So this is the PD2200. Now, I don't know. Here's QE7. Do we have a QE7 on here? I don't see a QE7. But we have a PR2200. So it may be one of these LDOs that we're looking for. And then the LDO comes on, powers this, turns this on, or turns it off. Because if it's on, then it goes straight to ground. And if it goes straight to ground, it pulls that center tap low. All right, let's get these resistors replaced. I have a donor board. I have a donor board that has these, and that way we don't even have to know which ones they are on the schematic, because it's quite frustrating to try to figure that out. So we don't have board view. If we had a board view, we can just click on that on there and it would tell us. So let's find that same location on here. And there we go. So it looks like it was this resistor and then that capacitor, right? All right, this resistor, that capacitor. Now I'm sure we could probably live without that capacitor, but that resistor definitely ties this line to that line. So let's go ahead and replace both those components, and hopefully this fixes the issue. Seems like we're on the right track anyway. All right, so what I want to do first is I'm just going to take those off and clean up the area and get prepped for the new components. Okay, perfect. So those are ready. We'll take these off one by one. Do the capacitor first. Now we'll do this resistor. I think we have a high likelihood that did fix the issue, considering that it was in the right location. All right, moment of truth. It should work by now. We've replaced all those components that got damaged. And let's see if it turns on. Keep an eye on the power meter. And look at that. We jumped up to an amp for a second. See if it does it again. Should turn off and come back on. Look at that. 1.9. And the fan's coming on. Okay, let's get this reassembled. That should wrap this one up. Let's see. All right, I got it assembled. Let's go ahead and plug it in and turn it on. We got our Dell screen. It's going to go through a CMOS reset, so that takes a second. and we're pulling 4 amps, 4.5 amps. So we never even were able to pull that much even when we were injecting that voltage. It was just kind of telling the system that the AC adapter was there, but it wasn't telling it all the way, like, you know, go ahead and pull the current that you need. So it was only one part of the AC detection. Now we're at 5 amps, that's perfect. It turned back off, it's gonna come back on. There we go. All right, and we got the CMOS reset screen. All right, I got it booted back into diagnostics, and if we look here, we can see the battery's charged at 57%, and right now we're getting 2 amps of current draw into the battery. It says it's charging, we're gonna unplug the charger, and it says discharging, and it switched back to AC adapter unknown, which is or not attached, so we'll plug it back in. Toggled back on AC adapter, 130 watt, and charging, and then we're looking for a charging current. Let's see if we can get to start going in there. Still sitting at 0. We're pulling 1.8 out of the charger, 4 amps. Now it says we're pulling 4 amps. Oh, there it goes, 3.5 amps going into the battery. So we're all right, kids. That tells you you need to be careful when you're prying this thing out. So the customer did damage his board. And so here's that donor board I was using. And if we take a look, this is my donor board, and this is the area where the chips were ripped off. And so they must have pried right here with a screwdriver at some point. So they either got it in underneath the case when they were trying to get the bottom cover off, or when they were just trying to lift the board up. And so the voltage dividers are way over here. See how far away they are from each other? So without the board view, it would have been a lot easier. If I had a board view, I could have just clicked on that and it would have taken me straight there, and I would have been able to look there. We knew we were on the right track, but we just didn't have the right, you know, the schematics only tell you so much on how things are laid out, but doesn't tell you where things are. And so it would have been helpful, and I would have been able to fix this a lot faster. But I'm happy I was able to save this motherboard, and I thought this was an interesting one, and I'd love to know your thoughts on this one, and thanks for watching.
I saved another laptop!